Alright, so this lesson is on identifying parent functions. So the first parent function, and the most basic one, is the linear function. And its defining characteristic is it looks like a line. So it could look something like that. It could go the other way, like that. It just has to form a line, and that's a linear function. The equation that you basically see for this is in slope-intercept form that you guys have learned before, and that would be y equals like 2x plus 1, something to that effect. The key characteristic to the equation is that x has nothing being done to it except for being multiplied by a constant, which is in this case 2. X isn't being squared, it's not being square rooted, there's nothing going on to x except for just numbers either being multiplied or added to it. So the next one is the quadratic function. And it's going to look like its name for it is a parabola. So it is kind of a U shape. And it can be, this is considered like right side up, or it could be upside down like this, either one. And its equation, it can take a couple of different forms. It can be something like x squared plus 3. It could be something like y equals 4x squared plus 2x plus 1. And really what makes it a quadratic versus something else is that the highest power used in that equation is the power of 2. So anytime you see x raised to the second power, sorry, if you hear a little noise in the background, that's my dog dreaming and barking in her dream. Sorry for that. Okay, sorry. So the next function is, we'll do the exponential function. So the exponential function it starts out where it's really close to the x-axis, and then it goes up super steep like that. And it can also go the other direction, but this is the typical one that you'll see. And with an exponential function, its equation will have some base number, which it could be 2, it could be 3, it could be 1 billion, but the special thing about exponential functions is it's raised to the power of x. So anytime x is an exponent, it's an exponential function. The next one, we'll change colors here, is the absolute value function. And its graph looks like a giant V. And its equation, and it could also be upside down, so it could look something like that as well. And its equation will have absolute value bars, so it would look something like the absolute value of x plus 6. And the key is that it has that absolute value symbols there, and that makes an absolute value function. The next one is we'll do the rational function. And this one's kind of weird. It looks like two parts. It's got a part like that, another part that goes like that, and it could also be in the other two quadrants. And rational functions are going to have x being what is in the denominator, and that will make it a rational function. The next function is the cubic function. Cubic will have a graph like that, kind of snakes up, and by its name you should be guessing that it is cubed, so x to the third. It could be x to the third plus 6 or minus something, but it is defined by that it's x to the third power, or some variable to the third power. Let's see. The last one is the square root function. Square root function, we'll start at 0, 0. Whoa. And we'll go like that. And just by its name, you should realize that it's going to have a square root in there, so it could be like x plus 6, but it has to have that square root in there, and that's what makes a square root function. So I believe, yep, that's all of them that we cover in our parent functions learning target. What I'll expect you guys to do is to match the graphs to the equations, and to just go from the equations to the name. So I would recommend creating flashcards for yourself that have the name of the function, a example equation, and then an example graph. And you have access to either graphing calculator, or if you go online and have a graphing calculator and type in different functions and identify them, that might be another way to practice. So good luck.